Welcome to the unit where we talk about the square root method. Square root method. Quadratic equations in standard form contain an x squared and an x term, which is the reason why they must first be factored to be solved. But some quadratic equations only have an x squared term, like this. So let's consider, now first of all, we say this has an x term. What this really is x squared minus or plus 0 times x minus 12 is equal to 4. But obviously the 0 times x is 0, so we just write it like this. That's why we say this only has an x squared term. And to solve this, we would say we have to set this equal to 0. So I subtract 4 from both sides to get x squared minus 16 is equal to 0. And then that factors into two binomials, x plus 4, x minus 4 is equal to 0. Some of you may know this as a difference of squares. And then from there, we would get our solutions. However, there is a much easier way to solve by using something called the square root method. So let's take a look at the square root method, the idea behind it, and see what advantages it offers in situations where we have only an x squared term. To use this new method, let's review some basic facts about square roots. Fact number 1. Every non-negative real number n has two square roots, the positive square root and the negative square root. The reason why we say non-negative is that we're also including 0. So 0 is neither positive or negative, it's neutral, so that's why we use the phrase non-negative. Real refers to any number you can think of, and n is simply the variable indicating what that number is. So once again, every non-negative real number has two square roots, the positive square root and the negative square root. Number 2, the two roots can be written more concisely using the plus or minus sign. As in this case, we have plus or minus the square root of n. Fact number 3 actually defines what a square root is and gives you an example of what a square root is. So this reads that the square root function is the inverse of squaring. So if I start out with this equation, x squared is equal to 9, in English we would be asking what number or numbers will give us 9 when we square it. So we are familiar with the idea of 3 squared is equal to 9. This case, what we're doing is we're giving you the answer. Here's 9. What number times itself will give you 9 when you square it? Now, in algebra, to solve this logically, we would do the inverse operation. We would take the square root of both sides. So on this left side here, I have the square root of x squared. Since they're inverse operations, we're left with x, because inverse operations undo each other. On this right side here, fact number 1 tells us that every non-negative real number has two square roots. So we have the square root of 9 for the positive case, or we could have the negative case, the negative square root of 9. Now, 3 times itself will give you 9, so the square root of 9 is 3. And if we're considering the negative case, we have negative 3. And that verifies when I go back up here into this original equation, I can replace x with 3. 3 times 3 is equal to 9. If I use negative 3, negative 3 times negative 3 is equal to 9. So x can equal to positive 3 or negative 3. In this final sentence down here, we have this written in a more concise manner, x is equal to plus or minus 3. Fact number 4, we're going to talk about a specific definition. Every non-negative real number n has a unique non-negative square root called the principal square root. When one asked what is the square root of n, it is inferred that the principal square root is being requested. So if you were asked what is the square root of 9, it would be appropriate to say 3, since 3 times 3 is 9. Important terms. The square root symbol right here is known as the radical sign, and the number underneath the radical is known as the radicand. So in this case, 9 is the radicand. So in summary, if you think of square roots as numbers, in the case of the principal square root, that would have one answer. Okay, so if we're looking at a number, what's the square root of 9? You would say 3. However, if you're looking at square roots as a solution, answer to an equation, or the context would indicate that this is going to be a solution to a problem, then you wouldn't have two answers, the positive case and the negative case. The square root method, example number 1. Here we have 4 different examples, and the primary idea here is to differentiate between the principal square root and all possible square roots. So for A, here we see the solutions to the equation x squared equal to 49 are two answers. X is equal to -7 or +7. Sometimes you can write it like this as well. You can write plus or minus 7. That's another way to write that. Now, letter B is an example of a principal square root. So we just have the square root of 64 is x equals 8. So we're looking at just the principal square root. So notice the difference between here we have an equation, here we just have a number. The solutions to letter C, the solutions to x squared equal to 21 are x is equal to plus or minus the square root of 21. Again, this is an equation, so we're going to consider all possible answers. In this case, there are 2 of them. However, for letter D, this is not an equation. We're referring to just a number. This is the square root of 81, and that is x is equal to 9. This is not an equation, so we just need the principal square root in this case. Example number 2. We want to solve the quadratic equation x squared plus 5 is equal to 10. So our first step would be to isolate the x squared term by subtracting 5 from both sides. That gives us a new equation, x squared is equal to 5. Our next step would be to take the square root of both sides. So I take the square root of x squared, and those are inverse operations. Some people say they cancel. The square root of x squared is equal to x. And on the right side, the square root of 5 is going to be plus or minus the square root of 5. And that's how we get our final answer. X is equal to plus or minus the square root of 5. If you take this answer and plug it into the original equation, you will get 10. Example number 3. So here we're going to solve this particular quadratic equation. X minus 2 quantity squared is equal to 4. So the quantity x minus 2 is squared. So find the square root of both sides first. I take the square root of x squared minus 2 squared and the square root of 4. And notice these cancel as they're inverse operations. So on the left side, I have x minus 2. And on the right side, I have plus or minus 2. Now, we have 2 possible answers here for x. So to avoid making mistakes, split the equation into 2 and solve. So on this left side, I'm going to consider the positive case, where x minus 2 is equal to 2. That occurs when x is equal to 4. I would also on the right side consider the case where x is equal to -2. And x minus 2 is equal to -2 occurs when x is equal to 0. So we have 2 possible answers. X can equal 4, x can equal 0. And if you plug both 4 and 0 into x, both times you're going to get 4 for an answer.